Good morning, my dear students. Today is our lecture number 5. In this lecture, we will discuss about algorithm, then efficiency of an algorithm, and then time and space complexity. So, what is an algorithm? An algorithm is a finite set of steps or the statements defining the solution of a particular problem. Every algorithm must satisfy the following criteria. What is the criteria? Number one, input. There are 0 or more values which are externally supplied. Then output, at least one value is produced as an output. Definiteness, each step must be clear and unambiguous. Finiteness, that means must terminate after a finite number of steps. Then effectiveness, each step must be definite and must be feasible. So these are the kind of characteristics or the criteria for any algorithm. Algorithm means simple, it is a collection of finite set of statement or the steps that is defining the solution of a particular problem. Then we are moving forward. What is the algorithm efficiency and why it is required? There are two aspects of computer programming. Number one, data organization, that is the data structure to represent the data of the problem in hand. Second, choosing an appropriate algorithm to solve the problem in hand. Okay? These are the two aspects. Then the choice of particular algorithm depends on following consideration. What are the consideration? Number one, performance requirement, that is the time complexity. Next, memory requirement, that is the space complexity. Then programming requirements. So these are the requirements. What is space complexity? Space complexity is of an algorithm is the amount of memory it needs to run to completion. Some reason for studying space complexity are: number one, if the program is to run on mostly user system, it may be required to specify the amount of memory to be allocated to the program. Then second, we may be interested to know in advance that whether sufficient memory is available to run the program. Third, there are maybe several possible solutions with different space requirements. Number four, can be used to estimate the size of the largest problem that a program can solve. Space complexity simple. How we can understand that concept? Okay, if we are using different kinds of variable into our program, how memory is going to be required to allocate these variables into the memory. We have to sum up all the space that is required by all the variables that we are going to be used in our program. That calculation is called as space complexity. Next, space needed by a program consists of following components. Instruction space, space needed to store the executable version of the program. Then data space needed to store all constant and variables. And then environment stack space. These are the three components which require space. Then what is time complexity? The time complexity of an algorithm is the amount of time it needs to run to completion. In the space complexity, we are talking about the space. In the time complexity, we are discussing about the time. We are calculating or analyzing the time of any algorithm. Some of the reasons for studying time complexity are: number one, we may be interested to know in advance that whether the program will provide a satisfactory real-time response. This is the main reason. Number two, there may be several possible solutions with different time requirements. Suppose we are having a problem. For solving that problem, we are having 2 or 3 possible feasible solutions. And how we can identifying okay, which one solution will provide the optimal solution for that particular problem. So we have to analyze, we have to check the efficiency of all the feasible solutions on the parameter of time and space complexity, and which algorithm produce the minimum amount of time and space requirement. That solution is the optimal solution for that particular problem. So there are two mainly parameters to check the efficiency of any algorithm which we are going to be select on the different possible options to solve any problem. What is this time space trade-off? The best algorithm, hence best program to solve a given problem, is one that requires less space in memory and takes less time to complete its execution. In practice, it is not always possible to achieve both of these objectives. We have to sacrifice one at the cost of the other. That means if we are going to select an algorithm, an optimal algorithm for any kind of a problem, we have to analyze all the possible or the feasible solutions or the algorithms on the parameter of time and space. So what is the ideal condition? That that algorithm must is produce the optimal solution, which required less amount of time and less amount of space into memory. But in actual or the practical situation, that is not possible. If any solution or any algorithm required less time, it will always take the less space. Both things are controversial. That means both things cannot be acquired at the same time. So we have to sacrifice one at the cost of the another. So that concept is called as the time-space trade-off. Okay.